So picture this, an AI agent that can rewrite your entire production code base. Now, what if you just handed it the keys? Yeah, that's a terrifying thought, right? Well, today we're going to dive into an architecture that's specifically designed to harness that incredible power safely. It's a system built on a really simple but powerful idea. Never, ever trust the AI.
Okay, so here's our roadmap for today. We're going to start by looking at the root access problem, which is basically a ticking time bomb in most AI projects right now. Then we'll get into the zero trust philosophy that completely diffuses it. We'll break down the 5 core pillars of this security model, see how it actually unlocks real-world business value, and finally, we'll take a peek into its really exciting federated future.
All right, let's get right into the core issue. Speaking as an architect, the very idea of giving an LLM direct commit access to a production repository, well, it gives me nightmares. It's the ultimate move fast and break things scenario, but with potentially catastrophic results. And that is exactly what we need to prevent. Let's not mince words here. Giving an AI agent root access isn't just a little risky, it's a massive vulnerability just waiting to be exploited. We're literally talking about handing over the admin keys to a system that is, by its very nature, non-deterministic. You know, that's not a potential security incident, that's a security incident that just hasn't happened yet. This slide really shows the massive shift from chaos to control. On the left, you've got the Wild West, agents doing a direct git push, state management all over the place, and basically no clear security boundaries. It's fragile and it's super dangerous. Now look at the right. This is a hardened, predictable system. The agents can't push code, they can only propose a patch, execution is totally isolated and then validated. This isn't just a slightly different approach, it's a fundamentally safer, more mature way of doing things.
So this brings us to the core philosophy of the whole system. We're not talking about bolting on some security features as an afterthought. No, this is security by design. It's where control is the absolute foundation, not just another feature. We're making a huge shift from a reactive security stance to a proactive one.
And the foundation of this philosophy is something the project calls zero trust invariants. You can think of these as hard-coded constitutional laws within the architecture. They are absolutely non-negotiable rules that the system enforces before anything happens. The default answer is always no, and every single operation has to be explicitly proven and verified. So let's break down these 3 core rules. First up, patch only. This means the agent can never directly modify the source code. It can only submit a patch for review, just like a junior developer would. Simple, but effective. Second, deny wins. If there is any confusion or conflict in permissions, the system automatically defaults to the most restrictive, secure rule. This basically kills any chance of privilege escalation bugs. And finally, the single writer principle. A global lock prevents race conditions and ensures that the system's state doesn't get corrupted when you have multiple agents working at the same time. Okay, now let's get into the real mechanics. How are these zero trust ideas actually implemented? Well, it all boils down to 5 specific architectural pillars that work together. Honestly, the best way to think about these 5 pillars is like a mature CI/CD pipeline, but for AI-generated code. You've got a clear separation of duties, super strict change control policies, automated ways to resolve conflicts, checks for data integrity, and of course, a final quality gate. It brings all the discipline of modern DevOps into this new world of autonomous agents. This first pillar, the separation of brain and hand, is just brilliant. The AI brain can come up with a really complex plan, like, say, refactoring an entire microservice. But the hand that actually executes the plan does it in a completely isolated sandbox. The code it produces doesn't get anywhere near the main branch until it passes through a whole series of automated tests in an approval gate. The planner and the doer are totally decoupled. The next 2 pillars lock down control even tighter. Patch only enforces the principle of least privilege in the most direct way possible. The agent can suggest, but it can never command. And deny wins is the ultimate safety net. It makes sure that any ambiguity in the security rules always resolves in favor of maximum security. This is how you prevent that accidental permission creep that plagues so many systems. And the last 2 pillars are all about maintaining integrity. The single writer lease makes sure that any changes to the system's state happen in an orderly, predictable fashion. No chaos. And artifact isolation is just critical for good code hygiene. It guarantees that temporary runtime files, things like logs or temp data, never get accidentally bundled into a patch and committed to your clean source code. Okay, so we've spent a lot of time geeking out on the architecture, but why does all this deep technical work actually matter? It matters because it solves a huge, very real problem that's stopping businesses from really using AI for serious automation.
This one phrase just nails the core business problem. See, on one side, you have large language models, they're brilliant strategists. And on the other, you have robotic process automation, or RPA tools. They're incredibly diligent workers. The problem is, you can't just let the unpredictable creative strategist directly control the worker without some kind of trusted layer in between. And that's the exact gap this architecture is built to fill.
And this is the big payoff. By creating that secure bridge, we can finally let an LLM design a complex business workflow, like, say, processing thousands of invoices with all their weird edge cases, and then safely hand it off to an RPA bot for execution with zero manual intervention. This is how you get to true, scalable automation and really start driving down those operational costs in a safe and reliable way.
So, let's look ahead for a minute, because this architecture is the foundation for something even bigger. The goal isn't just to control a single AI agent running on one computer. Oh no, it's much more ambitious than that. The project's roadmap is really telling. It started with a stable single machine version that's already done. Now it's moving into distributed execution with remote workers. But the end game, the real vision, is a federated network. I want you to imagine AI agents from totally different companies all collaborating on a shared open source project. Each one is operating under its own security rules, but they're all able to contribute to a common goal. That is the future this is building toward. And this brings us to a really fascinating final thought. Once we have built these robust guardrails that let AI agents write code and collaborate safely across different networks and even different organizations, what happens next? Are we going to see AI-driven open source projects where agents from competing companies contribute to the same codebase 24/7? The entire way we think about software development and collaboration could be on the verge of a massive transformation.